Hello friends, welcome to the lecture series of partial differentiation. In partial differentiation, how to find partial derivatives of various functions. In applications also, we use partial derivatives to find out Jacobian. As we discussed earlier, the Jacobian is the determinant of partial derivatives. In applications of partial derivatives, the sums on approximation, problems on errors we discussed. Now, the very important application of partial differentiation we are going to study is maxima and minima. In day-to-day life, we come across with maxima and minima. Maxima means what? Maxima is the maximum value and minima is the minimum value. Okay, maximum speed, minimum speed of the vehicle, maximum current, minimum current, maximum voltage, minimum voltage, then maximum output, maximum input. So we come across this type of situation in everyday life. In engineering also, this maxima minima plays very important role, because when you deal with any output related thing, then maximum output, minimum output of a machine, that is highly required. In maxima minima, technically, analytically, how to find maxima and minima of the function, that we are going to study. Maxima and minima. Here, maxima and minima is a part of optimization. The maximum value, minimum value, when you are going to optimize the profit, so you are going to maximize the profit. If you are going to minimize the expenditure, means you are going to optimize the expenditure, like this. Okay, there are certain functions. Those functions are neither maximum nor minimum at particular point. That point is called the saddle point. Saddle point is also important in applications of engineering, because in engineering problems we want the threshold point, where function is neither maximum nor minimum. Analytically, the maxima minima we are going to study. See, this is a function. F of xy is a function to be optimized. This is to be maximized or minimized. Or minimized. F of xy is a function which is to be maximized or minimized, and this function has two variables, x and y. So how to find out maximum and minimum value of this function at a particular point. Now, graphically, you are aware that in 12th standard, in 11th standard, what is maxima and minima? You have studied. Now, this is a function. This is f of xy. This y is equal to fx is a function, or f of xy equal to 0 is a function. And this point is a maximum point of this curve. This point is a maximum point of this function. And at the maximum point, the tangent, this dotted line is the tangent.
Sorry, Peter.
Geometrically, the maxima minima, in short I tell you. See, this is y-axis, this is x-axis, and this is a function which is to be optimized, which is to be maximized or minimized. This red curve is a function. Either you call it as a f of xy equal to 0 function or y equal to fx function. And this point is the maximum point. And at maximum point, if I draw a tangent, that tangent will be parallel to x-axis. and the slope of the tangent means derivative of y with respect to x. Okay, this represents the slope of the tangent, derivative of rate of change in y with respect to x. It indicates the slope of the tangent, and slope of the tangent is 0 because this line is parallel to x-axis, means this line is horizontal, and our horizontal line has slope 0. No slope means 0 slope. So here dy by dx equal to 0. Now this point is called the global maximum. This point is called global maximum. So why I am calling this as a global maximum? Because this is one of the point which has function which has maxima, and this line, dotted black line, is a tangent to this point, and slope of this tangent is 0 again at this point. We have two points where function has maximum. At this point function has maximum, at this point function has maximum, and if I name those points, point A and point B, the B point is a global maximum because function has the maximum value throughout at B, global maximum, and at this point the function will have the local maximum. Okay, just I am going to elaborate it like this. See, if I consider this interval, is it? This is O and this is M. In this interval, function has maxima at the point A. Then in the interval OM, this function has the global maxima because we are considering OM only. And if you consider ON, this interval, the global maxima occurs at this point, and the local maxima occurs at this point in the interval OM. In ON, this is the global maxima. Similarly, this point ABC, I am calling this as C point. At this C point, the function has minimum value. This is the tangent to the curve at point C, is it? And at this point also, if it is going like this, then at this point also, function has minimum value, is it? Now this point D, I am writing here D. The D at the point D, function has local minima. Function has local minima in the interval OM. And at point C, function has local minima in the interval MN. And if I consider the interval ON, complete ON, that this minima is the global minima, and this minima will be the local minima in the interval MN, in this way. Now, geometric, I told you how the maxima and minima is represented on the line, on the curve y is equal to fx. Now here particularly, we'll be having two variables and implicit functions will be there. It may be explicit also, but we'll treat as the implicit function and we'll be solving those problems. This function f of xy is to be maximized or minimized. Okay. Now some steps I tell you. First step. Step 1. First step. In the first step, what we have to do? In the first step, what we have to do? Take partial derivative of the given function with respect to x and equate it to 0. Take partial derivative of f with respect to y and equate it to 0. In this way, these two equations we have is equation 1 and equation 2. What we have done? Take partial derivative with respect to x and equate it to 0. Take partial derivative of f with respect to y and equate it to 0. In this way, two equations we have obtained. Now, in second step, once you get these two equations, equation 1 and 2, solve these two equations, solve 1 and 2 simultaneously for x and y. For x and y means what? Means if you solve these two equations, you will be getting different values of x and y. Solve 1 and 2 simultaneously for x and y and get the points. Okay, when you solve these two, so you will be getting some points. Now step 3, find value of r, find value of s and find value of t. So what are r, s and t? R is what? R is del 2 f y del x square, means double derivative of f with respect to x. This is double derivative of f with respect to xy. This is double derivative of f with respect to y. In this way, you will be getting those values r, s and t. Now, after finding r, s and t, then calculate rt minus s square and r. Calculate rt minus s square and r at the points obtained in step 2. Okay, in step 2 some points will be getting, and at all those points values of r t minus s square and value of r we have to calculate. And this nature of the values of r t minus s square and r at different points will decide maxima and minimum of the function. Now once you get rt minus s square and r at different points, then in step 5, if the step 5 is the conclusion step now, if rt minus s square is greater than 0 at those points obtained in step 2 and r is less than 0 simultaneously, then function has maxima. Function has maxima means function has maximum value at that particular point. Okay, this is the first part of step 5. Second part, if rt minus s square is greater than 0 and r is greater than 0 at that particular point, then function has minima. Third, this is one of the possibility if rt minus s square, because rt minus s square greater than 0 is common in a and b, and this r value of r will decide after getting this positive rt minus s square, r will decide whether the function is maximum or minimum. There may be the case like this, rt minus s square is negative, is less than 0. Then function has then function has neither maxima nor minima. Neither maxima nor minima. This is very important. If rt minus s square is less than 0, is negative, then function has neither maxima nor minima. Function has neither maxima nor minima. Where it occurs? Where does it occur? At saddle point. Now, this last case, this last possibility, if rt minus s square is equal to 0 at a particular point, then the further investigations are required. Because this is out of scope of the syllabus, investigations are required. You can directly state if rt minus s square equal to 0 at a particular point, then further investigations are required. Just you can directly state and you can move forward. Now, okay, these are the steps to find out maximum and minimum value of the function, or maxima or minima of the function. Now, once again I am going to repeat it. If f of xy, any function is given, first step, find partial derivative with respect to x, equate it to 0. You will be getting first equation 1. Yes. Find partial derivative of the same function with respect to y, equate it to 0. Second equation you will be getting. Then these two equations we have to solve for values of x and y. Means you will be getting points where function may be maximum, minimum, or further investigations are required, or neither maximum nor minimum, like this. And once you get the point, find r, s and t. Just for the convenience, I have written this, I denoted double derivative of f with respect to x by r, double derivative of f with respect to x and y by s, and t, like this. And once you get r, s, t, then calculate rt minus s square value at those points and r value at the points obtained in step 2. And step 5, here we will take decision that the function has maxima or minima, or neither maxima nor minima, or further investigations are required in this step. This step is important. If rt minus s square is greater than 0, means positive, r is less than 0 means negative, then function has maximum. Rt minus s square greater than 0, it is common in these two cases, and r is greater than 0 means positive, then function has minimum. Rt minus s square less than 0 means negative, function has neither maximum nor minimum, and rt minus s square vanishes means is equal to 0, then further investigations are required. You can directly state, because in research there are many views of the mathematician on rt minus s square equal to 0. So therefore, that's why I said this is out of scope of the syllabus. If this type of situation occurs, just you state like this and go ahead. Now, how to find out maximum minima of the function? Some problems we are going to discuss. In almost all the universities, one problem on maxima minima is asked in examination. Okay, function may be anything. Now, the question may be asked like this: discuss maxima and minima of the function. Discuss maxima and minima of the function x cube y square multiplied by 1 minus x minus y. Okay, this is the function. You may be given any function in the examination. Discuss maxima and minima of the function x cube y square in bracket 1 minus x minus y. So we are going to solve this problem. Now I'll not be writing here step 1, step 2, step 3 like this. But what is our step 1? Let us denote given function by f. F of xy or f. X cube y square into 1, directly writing, because I want to reduce number of steps in the solution. X cube y square multiplied by 1 minus x cube y square multiplied by x. X cube y square multiplied by y. Okay, this is given function. I repeat, you may be given any function in the examination. Now, find partial derivative with respect to x very carefully. What is partial derivative of this with respect to x? Keeping y constant, 3x square derivative of x cube. Y square is multiplicative constant because we are taking derivative with respect to x, minus derivative of x to the power 4 is 4x cube. Y square is multiplicative constant and derivative of x cube is 3x square. Y cube is multiplicative constant. Find those derivative very carefully. Once you get derivative and equate it to 0, and you may call this equation is equation 1. Then take derivative of f with respect to y. X cube is multiplicative constant because you are taking derivative with respect to y keeping x constant, and derivative of y square is 2y. X raised to 4 is multiplicative constant, derivative of y square is 2y, and x cube is multiplicative constant, derivative of y cube is 3y square, and you have to equate to 0. And this is our equation 2. This was our first step. Find partial derivative with respect to x, with respect to y of the given function, and equate it to 0. In the next step, these two equations we have to solve. Find different values of x and y, and you have to solve these two equations simultaneously so as to get the point of intersection of the tangent. Now, the equation 1 I am going to solve. What is this? What is common here? X square is common. I am taking it outside. Y square is common. I have taken it outside. X square, y square is common. That's why I have taken outside. Just simplification. Okay, simple simplification. Now x square, y square, if you take common, then 3 minus 4. X square, y square you have taken common, x will remain. X square, y square you have taken common, y will remain. Okay, this is equation 1. We are going to solve equation 1 and equation 2. Now, we have the product of x square, y square, and this bracket is 0. Therefore, here I am writing, because we have to solve this problem in minimum number of steps. X equal to 0 or y equal to 0 or 4x plus 3y is equal to 3. Okay, if you equate it to 0, then shift this on the left hand side and 3 will be on the right hand side. Means from equation 1, this I obtained. Now, similarly from equation 2, in equation 2, what is common? See, x cube is common, y is common, so I am taking x cube common and y common. In bracket, once you take x cube and y common, 2 in the first term, x cube common, y common means x into 2 will remain. X cube I have taken common and y I have taken common. Minus x cube and y, if you take common, this is 3y is equal to 0. Is it? Once again, x cube y, this x cube y I have taken common, 2 is there. X cube y I have taken common, x into 2 will remain, and minus is as it is. X cube y, if you take common, 3y will remain. Therefore, x equal to 0, then y equal to 0, because we have the product of this and this bracket equal to 0. Therefore, this is equal to 0, this is, or this is equal to 0, or this is equal to 2x plus 3y is equal to 2. Okay, directly I am writing. Now, we have this set of equations and this set of equations. This set of equation obtained from equation 1. This set of equation we obtained from equation 2. But we are solving these two equations. Remember, we are solving these two equations. Means these two equations, these two set of equations. These two set of equations we have to solve simultaneously. These two set of equations we have to solve simultaneously and get the values of xy, or in terms of order pair. Is it? Now what I am going to do? Take x equal to 0. This you have to do very carefully. I am taking x equal to 0 for x equal to 0. Okay, this is from set 1. This value is from set 1. This for convenience I am writing. And put x equal to 0, this x equal to 0 and x equal to 0. X equal to 0 and y equal to 0. Here. Okay, in this way I have to take this and this. Okay, x equal to 0 here, y equal to 0. Right? And therefore, for x equal to 0, y equal to 0, I am getting, this is one of the points. This is one of the point, and this point lies on this curve. Right? Is for x equal to 0. For x equal to 0 and 2x plus 3y equal to 2. From this pair, means for x equal to 0 and 2x plus 3y equal to 2, from this pair, if you put value of x here, this implies, if you put value of x equal to 0, what will you get? See, 3y equal to 2, and this implies y equal to 2 by 3. Y equal to 2 by 3. And therefore, the point is what? For x equal to 0, y is equal to 2 by 3. Is it? Now for y equal to this, the term of x equal to 0 is exhausted. Now y equal to 0. For y equal to 0. For y equal to 0, x equal to 0. That point is already we got. For y equal to 0 and x equal to 0, you can write here, but not necessary. Therefore, x equal to 0 and y equal to 0. First coordinate is x coordinate in order pair, and second coordinate is y coordinate. But this point we have obtained, and this is not necessary to write. This y equal to 0, x equal to 0. Y equal to 0 and y equal to 0, it has no meaning now. Then y equal to 0 and this one. See, I am writing y equals 0, and this I am going to solve. 2x plus 3y equal to 2. These two I am going to solve. This implies, put y equal to 0 here. If you put y equal to 0, what will you get? This implies 2x equal to 2, means x equal to 1. Therefore, the new point we have obtained, x is 1, x coordinate, then y coordinate. The next point here. Okay. Now, the term of y equal to 0 is exhausted. Okay. Now for 4x plus 3y is equal to 3. With this, okay, if you put x equal to 0 here and x equal to 0, what will you get? If you put x equal to 0 here Then 3y equal to 3, directly writing. No. This implies y equals 1. Therefore, new point we have obtained, x equal to 0 and y equal to 1. New point. Is it? Now, this pair I have taken, this with this now, for 4x plus 3y is equal to 3 and y equal to 0 and y equal to 0. This implies if you put y equal to 0 here, then 4x plus 0 equal to 3. This implies x equal to 3 by 4. X equal to 3 by 4. Right? So this pair I have taken. Now these two pairs for 4x plus 3y is equal to 3 and 2x plus 3y is equal to 2. So these two equations are simultaneous equations and simultaneously we are going to solve. So you can solve by your way. Means here 4x plus 3y equal to 3, here 2x plus 3y equal to 2. So this equation, equation 3 and equation 4. The 3y is common. The equation 3 minus equation 4. Writing directly. 4x minus 2x is 2x. 3y minus 3y is 0 and 3 minus 2 is 1. This implies x equal to 1. Now, I subtracted this equation from this and I got value of x. And you can just bring x component equal and you can find out value of y, or put value of x here in this equation 3 or put value of x in equation 4, you will be getting value of y. Okay, the equation put x equal to 1 in equation 3. Or you are free to put in equation 4 also. So what we get? We get 4 into 1 plus 3 into y is equal to 3. This implies 3y is equal to 3 minus 4 is minus 1 and this implies y equal to minus 1 by 3. And in this way, we have obtained the point 1, what? X equal to 1, where it is? It is 1 by 2, no? 2x equal to 1 means x equal to 1 by 2. I have written 1 here, not correct. 2x equal to 1 means x equal to 1 by 2. Now x equal to 1 by 2 and y equals minus 1 by 2. Is it? So this part is important, you know. So I am going to repeat once again. X equal to 0, x equal to 0, no meaning. X equal to 0, y equal to 0 is the point. X equal to 0 and this equation is this point. Y equal to 0 and x equal to 0, that point is already covered. The y equal to 0, it has no meaning. Y equal to 0 and this equation. You got this point. Now for these two. Try to solve these two simultaneously. You will be getting this point. So how many points on the curve we have obtained? And those points are stationary points. Stationary points. Is it? What is the first point? 0, 0. That I have written here. The next point is 0, 2 by 3. Next to that is 1, 0. Then 0, 1. 1, 0, 0, 1. Next one is what? Put y equal to 0 and x equal to 3 by 2. 3 by 4 means 3 by 4, 0 is one of the points we will get. 3 by 4, 0. And if you solve these two, we have solved these two equations, equation 3 and 4 simultaneously, and we obtained this point. Okay. These stationary points we have obtained. Now, RT minus S square, R, I will calculate all those points. Now I will check whether the function is maximum or minimum. Next step is what? Find R. R is what? It is del 2 f phi del x square. Is it? This is del x of del f phi del x. Is it? Del x of del f phi del x we have already found. See, del f phi del x is what? This is del f phi del x. 3x square y square minus 4x cube y square minus 3x square y cube. Now, its derivative again I am going to take, because I want r is equal to derivative with respect to x, 6x. Y square is multiplicative constant. Derivative of x cube is 3x square. 3 multiplied by this is 12. X square y square. And derivative of x square is 2x minus 6x y cube. This is r. Now, s I am going to calculate. S is equal to del 2 f phi del x del y. This can be splitted in this way, del f phi del y of del x, and del f phi del y we have already calculated. See, del f phi del y, where is del f phi del y? This is del f phi del y. 2x cube y, 2x cube y minus 2yx to the power 4 minus 3x cube y square. Okay, this is del y. Now, take derivative of this thing with respect to x. 6x square y minus derivative with respect to x I am taking 8x to the power 8 x to the power 3. Here derivative of x cube is 3x square, means 9x square y square SV4. Is it? Now t I am going to find out. T is what? Del 2 f phi del y square. It is what? Del y of del f phi del y. And value of del f phi del y, which is derivative, we already found, and this has been used here. See, 2x cube y minus 2yx to the power 4 minus 3x cube y square. Okay, this is already, we have already been used here. Okay, we have used this value here. Now, take derivative with respect to y carefully, partial derivative, keeping x constant. 2x cube is constant, derivative of y with respect to y is 1 minus 2, derivative of y is 1, x to the power 4 is as it is, multiplicative constant. Derivative of y square with respect to y is 2y, 2 into this is 6, x cube is constant. Just quickly, I found value of r, s and t. Okay. Now rt minus s square, this I have to calculate. RT minus s square, what is r? R is what? 6xy square minus 12x square y square minus 6xy cube. This is r. T is what? 2x cube minus 2x to the power 4 minus 6x cube y. This is r. T minus s square. S is what? S is this 6x square y minus 8y x cube minus 9x square y square. Last is x square y square. Okay. This is RT minus s square in general. Now the r is known to you. This is r. This is r. Because when you check the maxima and minima at different points, at those points, the RT minus S square and R will play important role. Now when you check maxima and minima, the one by one I am going to check. See, at the point 0, 0, first point I am going to check it. So what is RT minus S square? If you put x equal to 0, y equal to 0, x equal to 0, y equal to 0, x equal to 0, y equal to 0, you will be getting 0. If RT minus S square is 0, if RT minus S square is 0, then what to state here? The further investigations are required. Only this thing you have to state. And those investigations are out of scope of the syllabus. If RT minus S square is 0, just you state like this and move to the further part. At 0, 0, this is there. At 0, 2 by 3, at 0, 2 by 3. Because RT minus S square is 0, you don't calculate what is the value of R for that. If RT minus S square is the deciding factor, if it is 0, then you put this sentence and go ahead. Now, RT minus S square at this point. Now, put x equal to 0 and y equal to 2 by 3. Put x equal to 0, this will get removed. Put x equal to 0, 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 x equal to 0, x equal to 0, x equal to 0. In each term, x is present and x is, I am putting x equal to 0, and this will be 0 again. Here again, you have to mention like this, further investigations are required. At second point, further investigations are required. At 1, 0. At 1, 0, RT minus S square I am going to calculate. Means at 1, 0 we are going to calculate value of RT minus S square. Means it is very clear to put x equal to 1 and y equal to 0. To see the terms of y equal to y, means this term will be 0, this term will be 0, this term will be 0, and 0 multiplied by this will be 0. Put y equal to 0, y equal to 0, y equal to, again you are getting 0 here. Again further investigations are required. Is at all those 3 points, first, second and third, further investigations are required. Next point, at 0, 1. So I will check what will happen here. At 0, 1. Put x equal to 0 and y equal to 1. See, in this bracket, x is there, in each and every term x is present. Therefore, RT minus S square will be 0 again, because we are putting x equal to 0 and y equal to 1. Then further investigations are required. Okay, at 3 by 4, 0. At 3 by 4, 0, means put y equal to 0 and x equal to 3 by 4. So we are putting y equal to 0. Please check whether y is present in all the terms or not. Yes, here y is 0, y is 0, y is 0. Means this bracket is going to become 0 at this point, and 0 multiplied by this bracket will be 0, though it is non-zero. Minus RT minus S square I am going to calculate. What is the value? Minus, put y equal to 0, put y equal to 0, put y equal to 0, means this will be 0 again. Further investigations are required. Means at 5 points, further investigations are required, that I have stated. Now, the next point. Next point is what? 1 by 2, 1 by 3. Now, at 1 by 2, 1 by 3, at 1 by 2, at this point, 1 by 2, comma 1 by 3, what is RT minus S square? Do it carefully. RT minus S square is what? RT minus S square is this thing. I am not going to repeat right hand side. I am directly putting value of x, value of y. Do it carefully. x is 1 by 2, y is 1 by 3 square minus 12 1 by 2 square multiplied by 1 by 3 square minus 6x 1 by 2 1 by 3 cube in this way. Put x equal to 1 by 2 and y equal to 1 by 3. 6xy square, 6xy square minus 12x square y square, 12x square y square, 6xy cube, 6xy cube multiplied by 2x cube, 2x cube minus 2x to the power 4 minus 2x to the power 4 minus 6x cube y minus 6 here I am writing minus 6x cube y x cube y, is it, minus of 6x square y, 6x square y minus 8y x cube minus 9 x square y square, is it? Now you have to do it very carefully. You have to do it very carefully. This RT, you calculate this RT minus S square. This RT minus S square, use calculator and get the value. Just I am not making this calculation and wasting my time to do it. So this RT minus S square is a positive thing, you know. The positive number you will get. Use calculator and get the value. Maybe in the fraction. But RT minus S square is greater than that. Directly write. If RT minus S square is greater than 0, then we'll take the interest whether R is less than 0 or greater than 0 or not. RT minus S square is positive, RT minus S square, then what is R then? What is R? The R is what? What is R? Where is R? 6xy square minus 12x square y square minus 6xy cube. This is R. So R we have calculated. Is it? R we have calculated. Now at 1 by 2, 1 by 3 I want R. Okay. At 1 by 2, 1 by 3 I want 6, 1 by 2, 1 by 3 square, 12, 1 by 2, 1 by 3 square minus 6, 1 by 2, 1 by 3 cube. Is it? Now we are trying to calculate the value. Okay, this will be 9 multiplied by this 2 is 18, 6 by 18 and like this. Now the value of R will be, it is minus 1 by 9 will be the value of R, minus 1 by 9. And R is negative, it is less than 0. Now, if RT minus S square at this particular point is greater than 0, means positive, and R itself is negative, this implies that function has maxima at the point 1 by 2, 1 by 3. In this way we have solved all. What was the question? Question was to discuss maxima and minima. Okay, this was the question. discuss maxima and minima of the function. So we have discussed it. Means function has the maximum value at this point. And for rest of the point, the further investigations are required. But if you want, it is not asked here in this problem, but if you want the maximum value, the maximum value, where you will get maximum value? At this point you will get maximum value. So for maximum value, if you want maximum value, to put x equal to 1 by 2 and x equal to y equal to 1 by 3. X equal to 1 by 2 and y equal to 1 by 3 in given f. What is f? F is this. The maximum value how do you calculate? It is 1 by 2 cube, 1 by 3 square, 1 minus 1 by 2 minus 1 by 3. In this way, maximum value of the function you will be getting. And this, if you solve this thing, the 1 by 432 means this will be the maximum value of the function. Maximum value of the function x cube y cube in bracket 1 minus x minus y. In this way we have solved this problem. Okay. Now this is little bit lengthy, but the least number of problems we are going to solve on maxima minima. This is a game of practice now. If you have to have the practice on it, because while solving all these things, that there are maximum chances of committing mistake in plus minus, in multiplication, division, or like that. Now, next one. Find maxima and minima. Find maxima and minima. Second one. I'll little bit increase the speed here. Find. What was the question? In last problem, how the question was? Discuss maxima minima. Here, find the maxima and minima. Maxima means what? It is maximum value. Minima means minimum value of the function. X cube plus 3xy square minus 15x square minus 15y square, x cube plus 3xy square minus 15x square minus 15y square plus 72x. Okay, you may be given any function you may be given. Very quickly we are going to solve. Let us denote this function, given function, by f, or f of xy. X cube, 3xy square, 15x square, 15y square, 72x. Is it? Now, without wasting time, del f by del x I am finding derivative with respect to x, keeping y constant. Derivative of x is 1. Derivative of x square is 2x. Derivative of y term, this is constant term 0, plus 72. Derivative of x is 1. Now, equate it to 0. You may call this as equation 1. Del f by del y equals. Take derivative with respect to y now. Derivative of this is 0. Derivative of this is 2y. Is 6xy. Derivative of this is 0. Derivative of this is minus 30y. Derivative of this is 0. Okay. This equated to 0 is our second equation. Is it? Now, solve equation 1 and 2 simultaneously. Solve equation 1 and 2 simultaneously. So we have these two equations. This equation further I am going to simplify. 6 is common, y is common, I am taking it outside, and x minus 6xy, and what should I write here? Y I have taken common, here will be 5, is it? and this implies y equal to 0 because 0 by 6 will be 0, y equal to 0 and x equal to x minus 5 equal to 0 means x equal to 5. See, this set of values obtained from equation 2, the stationary point will not be like this 5 comma 0. The set of values we obtained from this. Now put y equal to 0 here, you will get value of x. That will be the required point. Put x equal to 5 and get the value of y. In that way you will get the order pairs. Now put y equal to 0 in equation 1. Putting y equal to 0 in equation 1 very clear. Here putting y equal to 0 in equation 1. If you put y equal to 0, putting y equal to 0 plus 72 is equal to 0. Now for y equal to 0, equation 1 becomes like this. Now try to simplify. 3 is common. This is what 3 is common and 2, 4. Is it okay? 24 divided by 3. Now try to find out, try to solve this quadratic equation. If you solve this quadratic equation, this 6 fours means 6 fours are 24. So you can use a calculator also here. Means x equal to x minus 6 and x minus 4. Therefore x equal to 6 and x equal to 4. These two values you will get. Once again, I am putting y equal to 0 in this equation. We obtain two values of x. Means what is the input? Input is y equal to 0, and what is output? Output is 6 and 4. Therefore stationary points. Okay, stationary points will be what? For y equal to 0. No? For y equal to 0, stationary points will be what? In order pair we have to write x is 6, y is 0 and x is 4, y is 0. For y equal to 0, these two stationary. Now put x equal to 5 here again. Put x equal to 5 in equation 1 and we get this implies I am putting x equal to 5 in this equation. The 3, 5 square, okay, x equal to 5 I am putting 3 y square, x equal to 5 I am putting plus 72 is equal to 0. Try to solve it very carefully because while solving I may commit any mistake. Just you please pay your attention also. It is 25, 75, 25 into 3, 3y square, and try to solve it very confidently and very patiently. This is 150 plus 72, this equals 0. This 3y square is what? 75 and this is 72. This is what? 147. 147 minus 150 is this. This implies y square equal to 1. 3y square equal to 3 means y square equal to 1. And this implies y is equal to plus minus 1. Okay, y square is 1. Y has two values, 1 and minus 1. Now for x equal to 5, we have two values of y, plus 1 and minus 1. Therefore, stationary points will be what? X equal to 5, y equal to 1 and x equal to 5 and y equals minus 1. Means these two stationary points we have obtained. See, these two means total 4 stationary points we have obtained. Now, at those 4 points, we have to check function, how the function behaves. Whether it is maximum or minimum, neither maximum nor minimum, all cases. The first part is over, stationary points we have calculated. Now R I am going to find. R is del 2 f phi del x square, means this can be splitted like this. Del x of, okay, in the same line I am writing because the solution, it should not be, look like lengthy. Del f phi del x we have already found, 3x square 3y square minus 30x plus 72. Is it? Value of del f by del x. This we have already found. Take derivative with respect to x very carefully. This is 6x, derivative with respect to x. Derivative of this is 0, derivative of this is minus 30, and derivative of constant, free constant is 0. R is 6x minus 30 in general. Now S I am going to calculate. It is del 2 f phi del x del y. This can be splitted in this way, del x of del f phi del y and del x of del f phi del y is 6xy minus 30y. Is it? Now take derivative carefully. Derivative with respect to x is 6y. Derivative of this is free constant term. Derivative of this is 0. T I am going to find. Del 2 f phi del y square is del y of del f phi del y del y of, now del f phi del y is 6xy minus 30y. Take derivative with respect to y now, keeping x constant. 6x is constant. Derivative of y is 1 minus derivative of y with respect to y is 1 is 30. The R in general in terms of x and y, S and T we found. Now we want RT minus S square. We want RT minus S square. See, RT minus S square, RT minus S square I want. R is what? Where is R? 6x minus 30. T is what? Again 6x minus 30. And S is what? Where is S? S is 6y. Means 6x minus 30 whole square minus 36y square. This is RT minus S square. And R is what? R is known to you. Here I am writing R. Is I am using minimum space so that the solution, complete solution, it will be managed to do on the single page, on the single sheet. R is what? 6x minus 30. Right? RT minus S square in terms of x and y, and R in terms of x and y we have obtained. Now at all those 4 points, I want values of this. Okay. Now see points here in the tabular form, because this I have to finish in minimum steps. These are the points. Points are 6, 0 is the first point. RT minus S square. Here R. Now RT minus S square I want. Okay. Be careful. RT, put x equal to 6. 36 minus 30. Put x equal to 6. 36 minus 30. 36 minus 36. 6 square is 36. minus y is 0, means this is 36. Means RT minus S square at 60 is 36. Okay. What is R? R is 6x minus 30. Because when RT minus S square is greater than 0, this is greater than 0 or positive, then further simplification means further value, means value of R is needed to be calculated. Now R is equal to, put x equal to 6, 36 minus 30 is 6, this R equal to 6 I got here. This is greater than 0 means positive. If RT minus S square greater than 0, R is also greater than 0, in that case the function is, here I am making a remark column, the function has maxima, function has minimum, when both are less than greater than 0, function has minimum. Okay. And minimum value you can find out. Minimum value you can find out. Minimum or maximum value, if needed, you can find out. Okay, means at 60, how do you find? Put 6 equal to x equal to 6 and y equal to 0 in that way. Okay, you can find out. I am not finding, but if it is required, you can find out. Now, at next point, what is the next point? Next point is 40. Is it? Put x equal to 4, put x equal to y equal to 0. If you put x equal to 4, 24 minus 30 is minus 6 and minus 6 square is 36. It is greater than 0. Because y is 0. Value of r, put x, this is x equal to 4, 24 minus 30 is minus 6. R is minus 6 and it is less than 0, negative. If RT minus S square greater than 0 and R is less than 0, the function has maximum. And maximum value, how do you calculate? Put x equal to 4 and y equal to 0 so as to get the maximum value. Then next point is what? Next point is 5, 1. Put x equal to 5 and y equal to 1. If you put x equal to 5, 30 minus 30 will be 0, and if you put y equal to 1 means minus 36 will be there. Put x equal to 5 and y equal to 1. Is it? If you put x equal to 5, 30 minus 30 is 0 and y equal to 1 minus 36. This is less than 0, negative. If RT minus S square is less than 0, no need to calculate R. You can say here not applicable, you can write not applicable. If it is less than 0, function has neither maxima nor minima. Neither maxima nor minima. Function has, at this point, function has neither maxima nor minima. And that is what called the saddle point. It is called, we call it as a saddle point, neither maxima nor minima. Now, what is the next point? Next stationary point? Next stationary point is 5 minus 1. 5 minus 1. Okay. Put x equal to 5, it will be 30 minus 30, 0. Put y equal to minus 1 square is plus 1. It will be minus 36, less than 0. It is not applicable again. And this same thing, neither maximum nor minimum. In this way, we have solved this problem. So once again, I tell you, if you want maximum value of the function, so please check at which point function has maxima. At this point. Then put x equal to 4 and y equal to 0 to get maximum value. If you want minimum value, then please check at which point function has minimum. At this point function has minimum. So put x equal to 6 and y equal to 0, you will be getting minimum value. Is it? The function may have more than one maximum value or more than one minimum value also. So we stop here. Thank you very much.